Action. Hi everyone. We are one more review of Trig before we move on to the the calculus portion of the course. I want to revisit the half angle and double angle trig formulas. You probably have these somewhere written down. Sine of 2u is 2 sine u, cosine u. Cosine of 2u is cosine squared u minus sine squared u. Or you could use 2 cosine squared u minus 1, or 1 minus 2 cosine squared u. You got this one. If you use the Pythagorean trig identity and substitute, you can get these other two. That's how these all come about. The half angles we've done. Sine of u over 2 is positive or negative, depending on what quadrant u over 2 is in, is where you use the positive or the negative. 1 minus, square root of 1 minus cosine of u over 2. Cosine of u over 2 is positive or negative, square root of 1 plus cosine of u over 2, depending on which quadrant you're in. And then you have your tangent of u over 2, and you've got these identities that we have used. All right, example 1. Let's just see. We're going to use the double angle stuff now for this one. Given that the tangent of u is negative 1/3 and u is in the third quadrant, does everybody interpret that part there as meaning the third quadrant? Find sine of 2u, cosine of 2u, and tangent of 2u. All right. Using the fourth quadrant. In my head, I sound like I said third quadrant, but I meant fourth quadrant. All right, so let's set this up a little bit. In our, we know we're in the fourth quadrant. The tangent of u is negative 1/3, and that is sine, which is y-coordinate, over cosine. So we'll go down 1 here, over 3 here, and we're at this point right here. Okay. Well, oops, let me draw it right here. So this is negative 1, this is 3. Here's our theta. Remember, make it with the x-axis. I almost forgot that for a second when I started making the triangle right there. And then r, negative 1 squared plus 3 squared equals r squared. That's that one right there, the hypotenuse. That's 1 plus 9 equals r squared. That's 10. And then the square root of 10 is what r is. So this right here is the square root of 10. Okay, that's going to let us find stuff we need to find. Okay, so the sine of theta is opposite negative 1 over hypotenuse, square root of 10. So let's multiply, let's rationalize the denominator there. So the sine is negative radical 10 over 10. The cosine of theta is the adjacent, so that's 3 over radical 10. And when I rationalize the denominator on that one, I got 3 radical 10 over 10. So there's my cosine, there's my sine. And tangent is, oh, we already know that, is negative 1/3. No, that was given to us. And we know we're in the fourth quadrant. And we know the sine's negative, the cosine's positive. So, sine of 2u is 2 sine u cosine u. We've got that written up here. In this case, that's 2 times the sine of theta. That's negative radical 10 over 10 times cosine of theta, which is 3 radical 10 over 10. So 2 sine u cosine u, 2, 3, I'm going to multiply that out, that's 6. Square root of 10 times square root of 10 is 10. And 10 times 10 is 100, and that is negative. So negative 60/100ths is negative 3/5 if I divide top and bottom by 20. So that's the sine of 2u. Cosine of 2u. Now we have all sorts of choices here. I'm going to use that first one just for the heck of it. And that's cosine squared u minus sine squared u. We have all the information. We could use any of the three, so there's no wrong choice here. And cosine squared, that is 3 radical 10 over 10. We got to square that, and then we got to subtract the sine squared, which is negative radical 10 over 10, and square that. Alright, I don't know if I was writing in the frame again. I have a problem with that. Let's see, 3 squared is 9, square root of 10 squared is 10, so 9 times 10, that's 90 over 10 squared, which is 100. I'll just write 90/100ths here, minus, and this is square root of 10, and negative times a negative is positive, so square root of 10 squared is 10. 10 squared is a 100. So that is 80/100ths, which is 4/5. That's cosine of 2u. And then tangent of 2u. You know, we do have, I didn't even bother writing it. We have sine and cosine. Tangent of 2u is we do have an identity for that. I'm not even going to use it now. I'm just going to use tangent of 2u is sine of 2u over cosine of 2u, which is negative 3/5 over 4/5. If I multiply this by 5/4, I get the denominator to be 1, so I don't have to write that anymore. 5's cancel out, and that looks like negative 3/4 to me. Alright, example 1 is in the books. Now, example 2. Got 3 things I want to find the exact value of, and I am going to use these are half angle problems. No, I've got mail. So, with our half angle formulas, the sine, oh wait, yeah, no, I am going to rewrite this as it is, half angle. So I'm going to rewrite this as the sine of 330 degrees divided by 2, because 330 is on our unit circle. This one, I did this because I knew you guys would really want to see another degree minute thing. I didn't put any seconds on here. If you feel deprived, I apologize. But if I take the 112, this is actually 112 and 30/60, or 112.5. If I double 112.5, I'm going to get 225, which is, so let's take 225 degrees divided by 2, and then the tangent of 7 pi over 12. Okay, if I were to take 1/2 of 7 pi over 6, I get 7 pi over 12. So this is a half angle here. U over 2 or 1/2 u, either way. Alright, so sine of 330 over 2. The half angle is sine of u over 2 equals, and 165 is in the second quadrant, so this one's going to be positive. And I got to, look what I'm doing here. 1 minus, whoops, let's write it. 1 minus cosine of 330 degrees divided by 2. Make sure I got the right thing there. Okay. So this is sine of u over 2. Okay, 330, where is that? That is like right there. And the cosine of that is square root of 3 over 2. Well, this is going to be a fun one. So let's take square root of 1 minus the square root of 3 over 2. Divide that by 2. We remember that 165 has a positive sign value. So, and then let's make 1 be 2 over 2 minus square root of 3 over 2, and then divide that by 2. And then let's write that as the square root of 2 minus the square root of 3 over 2. That's the numerator. And put that over 2. Make it a little further down. Okay. Let's take 1/2 and 1/2 here so that we really don't have that denominator there anymore. So now we've got the square root of 2 minus the square root of 3 over 4. Alright, another step here. I got the square root of 2 minus square root of 3 over the square root of 4. I'm splitting that up because we're not supposed to have a fraction under the radical when we're simplifying. And then I've got my final answer. I've got square root of 2 minus radical 3 over 2. Alright. That is the simplified version of the exact value of the sine of 165 degrees. Now, remember we took 225 divided by 2, so we'll use the half angle formula for cosine. And then 112.5 degrees. That's somewhere over here. Now this is cosine, so this is going to be a negative value. So that's negative equals negative square root, and cosine is 1 plus cosine of u over 2. So I'm going to take 1 plus the cosine, and u is, before we divide, it's the 225 degrees. I'm running into the next problem here. Over 2. Alright, 225, that's right here. Cosine of 225 is, the x-coordinate is negative square root of 2 over 2. So this is negative, and then that's 1 plus negative radical 2 over 2 over 2. Let me write 1 as 2 over 2 again to have that common denominator. So 2 over 2 minus the square root of 2 over 2 over 2. Lots of 2's there. And that's negative square root 2 minus radical 2 over 2. And that's still over 2. And I'm going to take that and times it by a half, so this will be just 1 times this by a half. And when I do that, I got negative, and then that is 2 minus radical 2 here. That's all under this big radical. And 2 times 2 here is 4. Okay, so I've got negative square root of 2 minus radical 2. I'm splitting this into two radicals because I don't want a denominator in our radical. And we have our final final answer is negative square root of 2 minus radical 2 over the square root of 4, which is 2. Alright, a lot of simplifying there that goes on. Okay, tangent. And we get to decide. I'm going to do the first one. 1 minus cosine u over sine u. 1 minus cosine of 7 pi over 6 over sine of 7 pi over 6. I don't know if one's better than the other or not. I'm just going with the first one. And 7 pi over 6. Let's see here. 6 pi over 6, that's that one. So that's right there. Looks to me like the cosine will be negative radical 3 over 2, and the sine would be negative 1/2. So 1 minus negative radical 3 over 2 over negative 1/2, and that is 2 and a double negative over 2 plus square root of 3 over 2 over negative 1/2. Now my numerator is 2 plus radical 3 over 2 over negative 1/2, and if I multiply by negative 2 over 1 to eliminate that, and multiply this by negative 2 over 1, the 2's will cancel. I still have a negative here. And that is looking like negative 2. I'm basically multiplying this by negative 1. Okay, I'm just checking my work here real quick. And that gives me negative 2 minus the square root of 3. I think that's it on that one. Alright, one more problem. Given that the tangent of u equals negative 3/4, and u is in the, if you look here, give me a guess. If you said second, you are correct. So u is in the second quadrant. Find these three values. Alright. Tangent of u is negative 3/4, and u is in the second quadrant. We are to find sine of u over 2, cosine of u over 2, and tangent of u over 2. So, let me first of all make a drawing there. And what quadrant are we in? We're in the second quadrant. So, it's sine over cosine. So, it's negative 3/4. But the y is going to be positive 3. The x is going to be negative 4. Negative 3/4 puts me right out here. Right here's my theta. This is 3 here. This is negative 4 here. I think you know by now that the Pythagorean theorem will give you 5 there for r. So the sine of u is opposite is 3/5. The cosine of u is negative 4/5, and the tangent of u is negative 3/4, which we were already given. And let's use our identities now. The sine of u over 2 is, I've got that identity right there, is now let's see, u over 2, if I take that angle and split it in half, it's still going to be positive. And the cosine is going to be positive, and the tangent will be positive. This will be in the first quadrant. U over 2 is in the first quadrant, so everything's going to be positive. And that's something you want to determine. All right. So we are going to take, for sine, we're going to take 1 minus the cosine of u over 2. So that is the square root of 1 minus negative 4/5 over 2. And that's 5/5. Let me write it over here. 5/5 for 1 plus 4/5 over 2. And we are looking at the square root of 9/5 over 2. That's times by half here and half here to get that simplified a little bit. That's the square root of 9. 9 times 1, 5 times 2 is 10. Square root of 9 over square root of 10 is 3 over square root of 10. Times it by square root of 10 here and square root of 10 here, and you got 3 radical 10 over 10. Now, cosine of u over 2, that's the sine of u over 2. Cosine of u over 2 is square root of 1 plus cosine of u over 2, which is square root of 1 plus negative 4/5 over 2. And that's 5/5 minus 4/5. I'm going to write 1/5 over 2 times by a half here and a half here. I got the square root of 1/10. Square root of 1 over square root of 10 equals 1 over square root of 10 multiplied by the square root of 10 to rationalize the denominator. And you got the square root of 10 over 10. And tangent. I'm not going to use the tangent identity. I'm going to use the sine over cosine. Sine of u over 2 is 3 radical 10 over 10. Tangent of u over 2 is square root of 10 over 10. If I multiply this by 10 over radical 10 and multiply this one by 10 over radical 10, that gets rid of the denominator and makes it 1 for me. Square root of 10's cancel, the 10's cancel, and all we're left with is a big old 3. Alright, kind of long video, but I'll have you work on this. And for your book work, okay, just bear with me for a moment, guys, because this took me a while to do, so I'm thinking that's a pretty long assignment. So I'm going to shorten it on this real quick here. If I can find the book. Oh, there it is. I was working from pages 397 and 398. Write that down. And let me look at this. What I gave you. They take a while, so I'm going to shorten the assignment from what I had written down here originally. It's a good thing I did these, huh? I wouldn't have realized how long this assignment was. Alright, I had 89 through 92. Oh, I think if we do 90 and 91 there, and then I have 105 through 112. Let's do 105, 106. What's on this other page here? Then 109 through 112. Let's have you do 110 and 111. All right, so that's half of what I had before. All right, that was worth the wait, right? Okay. Take care, guys. God bless you. I really hope I get to see you pretty soon here. Bye-bye.